Now we are moving to the last topic under Chapter 7, and that is going to be on compound interest. So for this particular lesson, we will be using the compound interest formula, calculate present value, and also understand and compute effective annual yield. All right. So when we talk about compound interest, this is the interest computed on the original principal as well as on any accumulated interest. So the accumulated interest is always every year. Okay. So the simple interest, it was only applied to the principal, to the amount borrowed or lent. Okay. But with compound interest, so after 1 year, the interest rate applies to the total amount now, the original and the interest. And then the following year, it's going to be that way. So every year, the amount, the principal technically gets bigger and bigger because it takes into it the interest after the year. Okay. So when we are computing for the compound interest compounded once a year, okay, so I want to make sure that we understand this part. This is compounded once a year, okay? So you will see in this particular topic that there will be a couple of different formulas. That is why it's very important that you read the problem very well. So this is the formula if it is compounded once a year. So the future value is equal to the principal times 1 plus r. T is not multiplied to r. T is now the exponent of the group 1 plus r. Okay? So we are still using the same variables in here. All right. So let's take a look. You deposit $2,000 in a savings account at Hometown Bank, which has a rate of 6%. Okay? So find the amount, A, so future amount, in the account after subject 3 years compound interest. Okay, so make sure that when you are reading your problem, identify some key parts already. Your P is the deposit, so this is your P, okay? Obviously, our R is the one with the percent, so this is the R, okay? We are looking for A, and what is it, subject? It's subject after 3 years. So that's our time, and make sure that you underline there or you highlight the word compound interest, okay? If you do not see the word compound, then automatically it's a simple interest, okay? That's that. So make sure you read those problems. So because this problem mentioned the word compound, so we know that the formula A is equal to, okay, P times 1 plus R raised, oops, sorry, my bad. That is supposed to be a parenthesis, okay? So make sure, okay, raised to T, okay? We don't multiply T in here. So let us find the A. So the P, the deposit is 2,000 times 1 plus our 6% is 0.06. And the time, it's 3 years, exponent of 3. Okay, so the nice thing about this is that if you follow the formula, if you identify what P, what R, what T, or what A is, it's so easy to work with it on the calculator. So all you need to do is type this exactly on your calculators, Desmos or handheld TI-84, and it's going to give you an amount right away. So, excuse me. So we are talking about money, so always run it up to 2 decimal places. So this amount is going to be at 2,382 and 3 cents. Okay, so that is the amount after 3 years. So asking for the interest, always remember interest is always the difference between the future minus the principal. It is always that way. Okay? And you will notice that the future value will always be higher than the principal. So to find the interest, our future value is 2382.03 minus the amount that was deposited, $2,000. Okay? And so in 3 years, this account earned $382.03. So this is the interest. Okay, so that's how easy we can find this is compound interest. So make sure you pay attention to the details of the problem. All right, now this is, as you can see, oh miss, why is it more complicated? Okay, this is the same as the formula earlier, only that there is an n. Why is there an n? Because this time the compound interest is paid several times within the year, okay? N times a year. So what will be the n, okay? So there will be keywords on the problem to know if it is compounded annually or compounded once a year, or if it is multiple times. So for example, so if it is saying compounded annually, so how many times in a year is that? That's one time a year, okay? It could be monthly. So how many months is there? How many times is it compounded? It's every month. So in a year, how many times is that? That is going to be 12 times. So the n, these are the values of your n, okay? Based on these keywords, okay? If it says quarterly, compounded quarterly. So how many times in a year? That's quarter, so 4. So 4 times in a year, okay? Let's say it says compounded every 4 months. If it is compounded every 4 months, how many 4 months are there in a year? Well, there's 3 of them, 4, 4, and 4, okay? If it says weekly, compounded weekly, how many weeks in a year? 52. Now, daily, if it is compounded daily, okay, we will just be sticking with the whole number 360, not 365. This is how it will be. This is the value of the n, all right? Annually, monthly, quarterly, every 4 months, weekly, daily, those will be mentioned in the problem. So you need to make sure that you pay attention whenever you are reading those problems, okay? All right, so let's have an example. You deposit 7,500, so we know this is our P, all right? In a savings account that has a rate of 6%, this is our R. The interest is compounded monthly. All right, monthly. So what does that entail? The n is going to be equal to 12, okay? So we need to find how much money, what will be the future value after 5 years. Okay, so let's get our formula. So remember, the formula will be A is equal to P times 1 plus R over N. Okay, we have the N because of the word monthly in here. And then our exponent, instead of just T, it's going to be N times the T. All right, so we replace our values. Our deposit is 7,500 times 1 plus the R, which is 0.06, over the N, which is 12 because it's monthly, okay? So 12 is going to be multiplied by 5 years, okay? So that's as simple as that, okay? Which you need to make sure you understand or you know which formula to use based on how you read the problem, okay? So again, plugging this whole thing in your calculator, make sure that you have it correctly. This is exponent, this is a fraction, all right? So the future value is going to be roughly about 10,116 and 38 cents, okay? So it's just for 5 years, but look, from 7,500, it grew to 10,000. So how much is the interest in 5 years? So the interest all the time is the future value minus the principal. So we subtract 10,116 and 38 cents by the amount that was deposited, which is 7,500. And so the interest of that amount is 2,616 and 38 cents. Okay, so that's how we get the compounded, the future amount with compounding a few times or several times in a year. So always be mindful of those keywords because they will give you the idea of what end value you will be using. Okay? All right.